Hello everyone. So in this video I'll be talking about mapping the solar system with quasars. And this video is from Kids Teach Kids. Now, this video is based on an article, and that article is from the Science. And Science is a magazine published by AAAS, which is the American Association of the Advancement of Science. And in the description below, you can find a link to it, and this is just a summary of it. And now let me go and talk about it. So it all starts with New Horizons. New Horizons was a spacecraft, and it was launched in 2006 to observe the planet Pluto, or a dwarf planet. And Pluto lies in the Kuiper Belt. And the Kuiper Belt is made of a lot of asteroids, and Pluto is the biggest space object in there. And the New Horizons went and took a flyby, which basically means it flew around Pluto, like that. And then once New Horizons had completed its mission, the NASA officers were like, hey, why can't we use New Horizons to observe more asteroids? And so they went and looked at more asteroids, and so there were many asteroids to pick from, and you probably already got your interest, but there was one that looks kind of like a potato, or an 8, the number 8, and it was this one. And so they were like, why don't we try that one? So New Horizons was sent to go to that one. And it went there, but while it tried to get there, it missed its location and it flew out. It went off course. Now, how did it get off course? Well, even if you threw like a ball at it, and the path changed slightly, it could have gone far away, not pointing to Arcot, which was the name of this asteroid. And the NASA scientists were debating on whether it was the NASA Horizons spacecraft that went off course, or Arcot that went off course, because Arcot is an asteroid, so it's not really following a elliptical path. So Mark Bowie, and he was one of the NASA mission officers, he said, well, I know it's New Horizons that went off course. And he was correct. So I'll tell you how he got this, and it's all about quasars. So what is a quasar? Well, this is how a quasar looks. And a quasar is basically a supermassive black hole, which is here, with gas swirling around it and plasma that is pushed away. And this gas is like throwing the plasma away, and that causes a beam of light like this. And the plasma is shining in both directions like an arrow. And quasars are shining a lot of light. It's shining so much light, and it's also very, 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 very far away. The closest quasar is 581 million light years, and just to give you perspective, 5,879 billion miles in a light year. And I was talking about 581 million light, so that's basically 581 million times 5,879 billion, which is 3,415,699 with 15 zeros. A lot of miles. So that's the closest quasar, and quasars are very far away. But they shine so much light that you can observe them here on Earth. Not with your naked eye, but with optical telescopes and radio telescopes. Now, quasars emit both light and radio waves. So optical telescopes take in light, while radio telescopes they take all the radio waves. And using these two, scientists can take the positions of quasars. Now, if you were now let's talk about a quasar map. So if you were to try if you were to try to use all the stars in the night sky and like use them as a map and say if there's a planet in between one, that this planet is between, let's say, star A and star B, then you might have a very useful map. But the problem with that is, if you use the stars in the night sky, then the stars are not always still. They can move. So your map would be very disorganized if the stars are moving. But quasars are so far away that you can barely sense their movement at all. So quasars seems like a better idea for using as a map. So just so you could say that if you have planet A here, then you could see it's next to quasar C, I guess. And if it moves like this, then you could say it's gonna move from quasar C to quasar D. Now you might say, that's a great thing. We can now do everything. But there's a few drawbacks between this, and the one drawback is that sometimes it can be very faint. The image of the quasar can be very blurry, but still they're very useful. The GPS relies on them, and NASA uses them to find the position of its spacecrafts. And that's how Mark Bury used to figure out that Arcot he was using instead of this plant. He was using Arcot as the trying to look at Arcot, and he figured out that Arcot was staying in a relatively elliptical orbit. So it must be certain that New Horizons spacecraft was off course, and he was right. So even though it's not perfect, it's still improving, and soon we'll get. So that's it for this video, and thanks for watching. So as I said again, see the link in the description below.